All right, good evening. Good evening. Welcome back to this is pre-calculus. We're going to skip question 3 because it's kind of real quickly. Okay. They only ask you about half the things I would ask you. So we're going to skip that one, and we're going to move on to question number 4 here. So it's like, okay, we have some kind of a radioactive fluorine here. Okay, fluorine 18. Again, this is the isotope of fluorine that we happen to be talking about. As we call it the green fluorine. This doesn't matter. Okay, patient is given a sample of this material containing 330, I guess, megabecquerels. Yeah, megabecquerels. That's a unit of radioactivity. It's the current SI unit. Curie is the old unit. We don't use curies anymore. We use becquerels. The patient undergoes a PET scan. This is like the number of emissions per second kind of a thing. Undergoes a PET scan and to detect the current medical. Okay, so they're looking for cancer, looking for metabolic activity indicative of cancer. Okay, after 174 minutes, 1/3 of the original dose remains in the body. So our T in this case is going to be in minutes because they're talking about after 174 minutes. Okay, so that's the only thing that's a little bit different between this problem and the previous ones that we've done. But what are they asking us to do? Write a function for this, how much fluorine 18 is in the body at the time t minutes after the initial dose. Round the value of k to 5 decimal places. We're going to try to make sure we pay attention to that this time, and I do not round intermediate calculations. Okay. So what we're going to do is we're going to start off with our radioactive decay problem. So that's Q is equal to Q sub 0 e to the KT. The book will put a negative sign in here. That's explicitly saying there's a negative. I can say, you know what, if K is less than 0, that's expected. So I use an implicit model rather than an explicit model, but that's really the only thing that's different. K is assumed to carry the negative sign inside of it. Okay, so that's the only thing that's going on here. Okay, so let's go ahead and give our problem a start here. So they're given a sample containing 30 megabecquerels. So that's our initial amount. So we're just going to say 330 here. Okay, e to the KT. What are they telling us what happens? They said after 174 minutes, 1/3 of the original dose is there. So we have, after, what is this, 174 minutes? So we have 174K or 174K. T is in minutes, it's 174 minutes. Okay, and they want 1/3 of that. So I think that's on the other side. I think I can even do that one. That's going to be 110. Okay, that's 1/3 of the original dose here. Okay. So what we're doing is we're solving for K because we're trying to get that as a value. So the first thing we're going to do is we're going to divide by the 330, divide by the 330. Okay, and we should have a 1/3 at the end here. Okay, so let's double check it. We should have 110. Oops, right, there we go. So we have 110 divided by 330. 30. So there we go. It should be 1/3. Let's put 333. So I'm just going to go ahead and say 1/3. So we have 1/3 of the original is equal to e to the 174K. We're trying to solve for K. So what I'm going to do now is take natural logs of both sides because I'd like to put K on the baseline. So we're going to have ln 1/3, okay, is equal to the natural log of e to the 174K. And then we're solving for K. So this business here, this is our third rule of logarithms. It's going to come down in front, okay? So it's going to come down in front there. So we have 174 times the natural log of the E. No, the natural log of the E is 1. Okay, that was equal to the natural log of 1/3. I'm going to go ahead and say, 3 to the negative 1 is equal to 1/3. So we're going to have natural log of 3 to the negative 1 equals 174K. We're going to pull this negative 1 down in front as well. So we're going to have 174K equals negative natural log of 3. So K is equal to negative natural log of 3 divided by 174. So that's going to be negative. Of course it is. It's decaying. Okay? If we were getting more of this stuff, then this would be a positive number. If you're dealing with a biological system, then this species is slowly dying off. The species will be going extinct. If it's positive, then they're having more of those. So if we have bunnies, they're going to make more bunnies. Okay, but if you have a species that happens to be going extinct, they're not replacing their population as fast as they should be. It's going to eventually go away. So we have our K, so we'll go ahead and do that. What did they want the decimal places? They wanted, sorry, I always have to check, double check, and triple check these things. Let's see here. They wanted, nope. Time span for the original dose in the body. Oh, there it is down the bottom. Sorry. So 5 decimal places. Okay. So we're just going to type this in. So we're just going to say K is equal to, we have negative. Remember to use this negative. Don't use the minus sign. Okay, that's an arithmetic operation between two numbers. This negative sign is the one you want. So we have one negative natural log of 3, or you could say natural log of 1 over 3. That's fine. Divided by 174. Okay, it's just that's typically how this was presented to me. So that's just how I like to do it. So we have 5 decimal places, 0.00631. We're just going to go 1, 2, 3, 4, 5. This 3 is going to leave this 1b, so we're going to say K is equal to negative 0.00631. 631. Okay, we could go more, but this is 1, 2, 3, 4, 5 decimal places. They got mad at me the last time, so I'm not going to make that mistake again. So we'll just go ahead with that. Okay. So what do we have here? We have Q of T is equal to, okay, how much did they give originally? So we started with 330. It's 330. 330. Okay. And now we're going to have E to the, okay, and now we have to go back to our K here. And that was going to be negative, so I'll say negative, oops, so where are we here? Negative 0.00, and we'll write down those digits. Okay, 631. 631 T, knowing that T is going to be in minutes. Okay, so that should be our calculation there. That's our formula. That's our function that we're going to go. Okay, so check. So hooray, we got the green dot, so they were very good. Okay, what is the half-life? Round to the nearest minute. Do not round intermediate calculations. So this is reasonable. Okay, this is reasonable. So now that we have our K, which is almost always the way that this problem is going to be pitched to you. Okay, it's always going to be find K or determine K, and then find the time that something else is going to happen. So now they want to know the half-life. So we're going to say Q is equal to Q sub 0 e to the negative 0.00631. So they don't round it, but previous one they rounded it to 5. So okay, I guess we'll work that. And then we have T. Okay, so they said what's the half-life? That's when 1/2 of the original is left. So we have 1/2 Q sub 0 is equal to Q sub 0 e to the negative 0.00631 T, and all we're going to do is divide by both sides by Q sub 0. Okay, Q sub 0. I often call this Q sub 0. This is Q NAUGHT, Q naught. That's the way that English people say it. Since I had a lot of English professors when I went to school, it's very typical that it's Q naught. It's not this. Okay, it's not Q, not this naught. Okay, not this naught. Okay, it's nothing. Q sub 0, so it's NAUGHT. It's all for naught. That's what that means. It's all for nothing. Okay, so Q sub 0. So that cancels. Okay, so we have ln of 1/2. Or I'm sorry, we don't have an ln yet. We just have 1/2 equals e to the negative 0.00631 t. We're going to take natural logs of both sides because we're trying to figure out what t is. So we want natural log of 1/2 equals natural log, okay, of negative 0 point, sorry, took the natural log of both sides in order to pull this stuff down in front. Don't put a negative number inside a logarithm. That's going to give you an error. So we want outside is fine. So negative 0.00631 t times the natural log of e. We know that's 1. So all we're going to have left here is t is equal to natural log of 1/2 or negative natural log 2 if you prefer, negative 0.00631. That's going to be our half-life of this fluorine 18. Okay, so that's what we're going to have. Right, so we have, that's a mess with the calculator, right? So natural log of 0.5, that's going to be a negative number. It's less than 1. I know it's going to be a negative number. Divided by, right? We're going to say negative 0.00631. I'm a little nervous because they said 5 decimal places, but I don't really trust them because they said don't round. But I take their word for it. We have negative divided by negative, we will get a positive number. So we end up with, this is still in minutes, right? This is 109, 109.84. So how many decimal places did they want us to write this down to? Do not round, oh, to the nearest minute. Okay, that's nice. So we're going to say this 0.8 here, that's just going to change this 109 to 110 minutes. So almost 2 hours. Okay, that's about what we expect. So I'm just going to go off and say 110. My fingers are crossed. Hopefully we're going to work this out. And then, hey, we got a green check mark. So we should be all set. Okay, so I'm going to keep these short so you guys can follow along. Hopefully this is helping. And we will come back to you in the next video. This, by the way, this would be a reasonable quiz question. I'll see you in the next video.